This is redstone. It can be used to make all sorts of things, like computers, which I'm currently building now. But what if you could make redstone using no redstone? Well, that's what I wanted to do. You can transmit signals in other ways, for example using water here, but what I find personally the easiest is slime blocks, pistons and redstone blocks, where you can transmit signals at 2 ticks per 14 blocks. That's almost the same as a normal redstone line, which does 1 tick per 16 blocks. Okay, now let's take a look at logic gates. So every single logic gate is just made up of OR gates, which if either of the inputs are on then the output is on, and NOT gates, which just invert the input. So this is a really simple OR gate that I made. If any of the levers are on, then the piston will push forward, placing the redstone block next to the other piston, which pushes the redstone block next to a lamp. And this is a NOT gate that I made, where the piston is automatically on top of the redstone block, and when it's on, the redstone block gets pushed out of the way, deactivating the piston. Okay, now take a look at this AND gate. It's just made up of a combination of 2 NOT gates at the start, an OR gate, and then a NOT gate. So the lamp will only turn on when both of the inputs are on, because then the middle line turns off, and the last torch can turn on. So to replicate this with pistons and redstone blocks is actually pretty easy. It's just a combination of the different circuits that I showed you earlier. Here you can see there are 2 NOT gates, an OR gate and then a NOT gate. So the lamp will again only turn on when both of the inputs are on. So we just made our first kind of complicated logic gate, and now I'm going to be making the rest of them. Okay, so this is a simple OR gate with no inversions. This is an AND gate with inversions at the start and the end. This is a NOR gate with inversions only at the end. This is a NAND gate with only inversions at the start. So an XOR gate is a little bit more complicated, but here's the circuit diagram for it. It's basically just saying it has to be at least one of them, but not both of them. And this is just a combination of other logic gates that I've already made, which is just a combination of NOT gates and OR gates, which I've already made. So basically, it should be possible. So I got to work building it. It took way longer than it probably should have done. I had to redo the whole second half at one point. But yeah, it's finally done. The output lamp only turns on when exactly one of the inputs are on, just like this XOR gate here. These slime blocks are to separate the input into 2 separate paths, so you can calculate OR and NAND at the same time. Okay, let's make a simple combination lock with this. A combination lock is basically just an AND gate, but with more than 2 inputs, and some of the inputs are inverted if you want that to be 0 when the combination lock opens. Okay, I made a start, so the light there only turns on when the right combination is pressed, which here is the 2 outer lamps. If any other combination is on, then the light won't turn on. This is because you invert all the inputs that you want to be on, and don't invert the ones that want to be off. And then you have a redstone line, well, the equivalent of redstone line, running all the way across, connected to a NOT gate, which is connected to the light. So this is essentially just a 4 input AND gate with some inverted inputs. So if you hook this up to a piston door, you get it so it only opens when you type in a specific code. Any other combination and it will close. And we did it all without any redstone dust, repeaters, comparators or torches. Only pistons, redstone blocks and slime blocks. Okay, now I want to try and make something a little bit more interesting, a 7-segment display. If you don't know, a 7-segment display is a display with 7 segments, which you control individually to display numbers. For example, if you choose these 2, then you can display 1, or 7, or 6, or any other number. Okay, I did the 6 the wrong way around, but you know what I mean. You've probably seen these in like microwaves and stuff. Anyway, I got to work building the display screen, which is the easy part, so it shouldn't take me too long. The next part's going to be way harder. That next part is encoding, which is coding in which segments are displayed when a specific number is shown. For example, if you want a 0, then you turn on all the pixels except the middle one. Sorry, all the segments. So I got to work building a line for each of the segments and encoding with a redstone block which numbers would have which segments. This is 0 completed, so when you press a lever, all the pixels turn on apart from the middle one, displaying a 0. Okay, now I need to build the rest of the numbers. Okay, it's done, so you can choose any number from here and it will display it on the screen using the 7-segment display. Pretty cool, right? Bearing in mind I haven't used a single dust, repeater, comparator or torch. Now I just need to figure out how to build a sequencer so I can eventually turn it into a counter that counts up. Here's me trying to figure out what to do for ages, so just enjoy the music. Okay, I finished, so whenever you press the button, the lit up lamp moves right by 1. Now this is me adding it to the original system. I had to change it a bit because some of the dimensions were off, so it took ages, but it's finally done. Okay, I've built a 1-digit number counter, so when you press this button, it will go from 0 to 1, and then if you press it all the way to 9, if you press it again, it will take a while, but it will loop back to 0. You can see the minecart coming all the way back around here. I had to choose a furnace minecart because otherwise it'd be too fast and do 2 at a time, so it's pretty slow. But yeah, it's coming now, and it's turned back to 0. I also built a carry out function so it says when it turns from 9 to 0 to send a message to the next digit to increase by 1. So you can increase the first digit all the way up to 9, and then when it gets to 9, if you press the button again, it will take a little while, but eventually, well, I think you can see the minecart coming up there. Eventually it will turn to 10 with the carry out signal. 3, 2, 1. Yes, it worked. And when you press the button at 19, it will again carry over to 20, even if it takes about 5 minutes. Now this is really cool because it's actually infinitely stackable, so you can make one that goes up to like 1,000 or 10,000 or 100,000 and so on. It will just take about 5 hours though if you do it at like 10,000. Okay, now's a good time to talk about the sponsor of my video. That was a joke, no one's ever going to sponsor my videos. I don't even have 10,000 subscribers, although I can, if you subscribe. Anyway, now I want to build a calculator. Since an adder is just made up of a bunch of different logic gates, and we've already made a bunch of different logic gates, it should be possible, but it will definitely be complicated. I'm going to play a different music track this time, just enjoy it. There was more, but for some reason the recording just cut off halfway through, so it just stopped. So this is the first input, this is the second input, that's where the result is. This is the carry in, and this is the carry out. Yeah, so if I stack this 8 times, I can get an 8-bit binary adder. Okay, here we have our 8-bit binary adder with redstone, but using no redstone. Let's try a calculation. For example, 5, that's 1 and 4, so 5, it just appears there. And then plus 7, so that would be the last 3, is 12. Perfect. And if you're wondering, I didn't just build that all by hand. I just built one module and then stacked it with World Edit. Look how satisfying this is. If I entered 256 by pressing all of the levers on one of the sides, and then I press this lever, it will carry all the way across and end up with just one at the end. I haven't built the carry out lamp yet, so it won't show. So it will just show as 0, 0, 0, 0, 0, 0. Just imagine a light at the end was on. This is why it's called a ripple carry adder. You can just see it rippling across. So cool. Okay, now I want to make a pixel display. So I couldn't figure out any way to make it 2x2, so I'm going to have to resort to making it with gaps, which is a bit annoying, but it's fine. Okay, now that I've separated out the different pixel rows, I can use the same technique that I used in the counter over there with the encoding, to encode different pictures onto the screen. Okay, it's finished. It's not very good because I had to use the one with gaps instead of just a 2x2 pixel display, so it's a bit like, it doesn't really look very realistic, but there you can see is a smiley face, sad face, and then this one is encoded to a shocked face. So yeah, pretty simple. I guess quite similar to the counter over there. Okay, I think that's it for this video. If you guys have any more ideas, then put them in the comments, and if this video does well, then I'll probably make another one. So yeah, subscribe and stuff. I also want to take this opportunity to show off how I've been building Python in Minecraft. So I saw a video yesterday of Matt Batwings making Microsoft Word in Minecraft, and I realised I pretty much did the exact same thing, but way better and way more compact. So that was 6 years ago though, so I guess he's improved, but I can say now I'm better at Redstone than Matt Batwings. My one also has a cursor, right arrow, left arrow, up arrow, down arrow, backspace and enter. And it can hold way more letters than his could. So yeah, check out my other videos and subscribe. Goodbye.